So in the last session, we discussed about why Spark is required. Just a recap I will do why Spark. And the very first reason is a single platform for different kinds of data processing. Second is it is in-memory processing. So these I said are the two main reasons why Spark is being used in the companies nowadays. And we also saw the data structure that is being used in Spark to represent our data. So the data structure is nothing but the RDD. We also saw what an RDD means. RDD is resilient, distributed data set. So data set means it is a collection. So it means it is a distributed collection which is resilient to data loss. Along with that, we also saw it is immutable. It is lazy. Any most of the transformations that we do on RD are lazy, and we also saw what a lazy is. And one more is it can be cached. So these are the properties that uh, we described with respect to the RDD. So and finally we summarize that RDD is nothing but a collection. That's all. Just like we have a collection, list, set, map, all those stuffs, RDD is also one of the collections. And just like we applied our map higher order function, filter higher order function, a reduce higher order function, for each higher order function, a fold higher order function, sort by higher order function, in a similar fashion you can apply all those higher order functions on a RDD as well for doing all kinds of operations on an RDD. So if you remember, on the list of users, we only selected the salary and the name and the city of the user. We wanted the size of the uh, length of each colors of the collection. So such kind of transformations, if you want to do an RDD, so we can use the all those higher order functions and do all the operations that is required. So we'll start here with few of the examples. First, we'll be taking very simple examples to understand all the concepts of Spark. So the concepts of Spark are important. So just open the Spark core. I mean to say, if you have by now, I think everybody should have this Linux box. Just search for IntelliJ there. Open IntelliJ. So once you open IntelliJ, you should have Spark core here. If you don't see Spark core or Spark examples on the left panel, just go and open here. Open this, click on this open button. So it should be inside downloads folder. In the downloads folder, you should have the training folder. In the training folder, you should have Spark folder. In the Spark folder, you should see Spark core. Just press OK. Everything is in the, I will just show it once again. So it will open the home folder, which is nothing but Kafka. Home folder is Kafka. In that you will see downloads folder. In the downloads folder, you should see training folder, and in the training folder you should see Spark. So most of the examples are here itself. So one among them is the Spark core. So just to understand the concepts of Spark, so I shall be using some simple examples to understand it more clearly. Open this folder from your IntelliJ. So it should look something like this. So you should have a project structures on the left hand side like this. Also there is a document. So there is a document on how this code is organized. So you can also check that document. In my training folder, if I go to data mantra here, training Spark. So if you go to Spark here, there you will see some documents. One of the document is, so where I have kept it. So it's in the testing folder. I have shared the training folder. Inside that you have to go to the Spark folder, then the testing folder. Inside testing folder, you will see Spark batch. So this document will help you go through the content. So we will be using the sales.csv file, which has some simple elements like it has four fields. That CSV file has four fields called transaction ID, customer ID, item ID, and amount paid. So these four columns we have in our sales.csv. If you want to look in here, so you can search for a file using the Control Shift N. So Control Shift N is to search for a file. So here you can search for sales.csv. So this is the data we have with us. We have our transaction ID. The very first column is transaction ID. Second one is the customer ID. Third one is the item ID. And fourth one is nothing but the value of that item. 100 rupees, 505 rupees. These are the values of that item. So this data we'll be using to run the programs and understand the concepts of Spark. So the very first example that we'll be looking into is load data. Load data is the first example that we'll be looking here. So it is just to load the data. We'll not do any processing here. We will simply load the data to Spark, nothing else. So let's see how it looks like. So the program name, we know that it is load data.scala. So we can check here. The program name is load data.scala. So you can search for load data.scala. Control Shift N. Data.scala. And one more thing to remember here is you may be getting some errors here. All the libraries may not be downloaded. So you may be seeing something in red colors. Some Spark context will be in red color. Spark conf may be in red color because the libraries may not be imported. So so you have to have internet connection within your VirtualBox. If you have internet connection in your VirtualBox, all the libraries will be downloaded and all the errors should go. So just make sure that you have internet connection in your VirtualBox. So once you have that, everything should be fine. If you face any problem, you can just ping me. We can try to solve that problem. So let's see how the program works here. As I said, this program is just to load the data. So the very first thing we are trying to create is a configuration object. Just like we create a configuration object for anything where you want to override the default configurations. So we are creating our own configuration object called the Spark conf. So any default configurations of Spark can be overwritten with this Spark conf. So as of now, there is nothing there. As of now, we are not overwriting. We will see later how some of the parameters can be overwritten here, or configurations can be overwritten. Next, we have our Spark context. So this is our entry point to the Spark application, Spark context. So this I'm explaining with respect to Spark 1.x. So here we are using Spark 1.x. In Spark 1.x, we have Spark context. This is for score. If you want to use Spark SQL, there is SQL context. If you want to use Spark streaming, there is something called as streaming context. So all these things belong to 1.6. In Spark 2.0, you have Spark session. That will also be seeing as we continue with the training. X. And it internally has all these. Spark session is a wrapper around your Spark context. So from Spark 2.x, it will be Spark session, and internal to Spark session, you have all these things. So you can think of these are all your entry points to your Spark. If you want to write any application in Spark, you have to have all these things. And the very first parameter is nothing but the master. So I will make understand what is this master. But first we'll see how to run this program and how we load the data. This is an important parameter, master. It is not a parameter to ignore. So I will go through this. It requires some more understanding to know what is the first parameter. Second parameter is nothing but the name. Third parameter is the object that we are, the configuration object to override the default configurations. Now the very first thing we are doing is we are reading our data. So this is how we read the data from the file system. So textFile API is the API that we use to read the data from the file system. So you need to specify the path of the file, and it will return an RDD. So this actually returns a RDD, which is nothing but a collection. So it will return an RDD of string. So textFile API, what it does is, so just to give a understanding, so we have our MapReduce, and it has input output module. I mean, every processing framework should have an input output module, because it has to interact with the file system to read the data and write the data. The core of that framework is to process the data, but to process the data it has to read the data from somewhere. So it will have a separate module which can interact with the file system for reading and writing purpose. So this module is so flexible, it can read the data from local file system, it can read the data from S3 file system, it can read the data from HDFS, it can read the data from Azure Blob. We know that any processing framework can read the data from these things. Now Spark is also a processing framework. Spark is also a processing framework. It should also be working in a similar fashion. Spark also does the similar fashion. It can read the data from local file system, or it can read the data from HDFS S3 file system, or HDFS file system, or Microsoft Azure. I think some other file systems are also supported. Future also it will be supported with different file system. It has to be very versatile. Now how it is made versatile is, I mean, they already, that module already exists with the MapReduce. So they use the same module. That same module has been integrated with the Spark application, because they don't want to reinvent the read-write operations. The read-write operations are already versatile and very good and robust. So they just use that existing module which was there with the MapReduce, and they have integrated with the Spark. So Spark also uses the same module. Only thing is they have written a simple wrapper APIs on top of this. So there are wrapper APIs. So textFile API is one of that wrapper API. So textFile API is usually used to read simple CSV file. It is not used to read any JSON file or an XML file or a binary file. It is not, or an Avro file or a Parquet file or a ORC file. It is not used for reading any other format files. It is usually used to read simple CSV file. So it what it does, it treats each line as a record. And each line is treated as a string. Each line is treated is a record as per this text file, and that record, each record is treated as a string. So what it means is, whenever we call this API, it reads the file from the file system and returns a collection of of records with each line as a record. So our RDD is nothing but a collection. It returns an RDD, which is our collection, which is nothing but a RDD of string. As I said, we don't need to specify the data type. If you want to explicitly specify, we also know that we can specify the data type as RDD of, just like we specify list of string, we specify RDD of string. So if it shows in the red mark, means we haven't imported that. So there itself it gives a option that press Alt Enter. If you press Alt Enter, automatically it will be imported. So it treats each line as a record, and each record is a string, hence RDD of collection of string. So it is nothing but this is our collection. This is our collection. This will be the first element of the collection, and it will be treated as a string. This is the second element of the collection, which will be treated as the string. Third element of the collection, treated as a string, and so on. So once we use a Spark text file API, it returns a collection of string. Here we call it as RDD in Spark. Earlier I said that the operations, most of the operations that we do on RDD is lazy. Here also it is the same thing. We are trying to read the data from the file system. We are trying to read the data from the file system using the text file API. The data will not be read. This code or this expression is not evaluated. It is not evaluated immediately because it's a lazy operation. It will be, as I said, the lazy operations will be evaluated only when you ask for the result. Only when you ask for the result. The way you ask for the result is through some APIs. One of the API is collect. You can imagine here now, collect is a way to ask for the result. Give me all the red data. I am trying to collect all the red data from the file system. So collect you can think of as a way of asking for the result. Only when you call the collect API, the data will be read from the file system. So based on these concept, there are two jargons that are associated with the Spark. So those two jargons are transformations and actions. Transformations are lazy. Text file API. Whenever you use the text file API to read the data from the file system, that is a kind of a transformation. The data from the file has been transformed to a collection. So all those things are lazy. Actions are nothing but which will actions trigger evaluations of lazy expressions or transformations. So there are lot of transformations. One by one we will see. So the transformations are nothing but the text file API is a transformation, is a lazy. So if you see map higher order function is also lazy in Spark. Filter, All these are transformations. We transform the data. Similarly, there is reduce by key. We haven't seen these things. We'll see all these things. So all these are are lazy expression. Flat map. There is something called as map partition. We'll see these things. All these are lazy operations, meaning they will not get evaluated immediately. So actions are nothing but the trigger which will trigger evaluation of lazy operations. So for easier understanding, what you can think is you are asking for the result, and the lazy expressions only get evaluated when you ask for the result. So actions are the way of asking for result. So there are multiple actions, like collect is one of the action. There is count action. There is a first action. For each is an action. Reduce is an action. Many other actions are there. Collect, count, first, for each, save as text file. These are all the actions. Only when you call these methods, all the lazy transformations will get evaluated. Otherwise, your lazy operations will never be evaluated at all. If you don't call an action, your program will not be evaluating any data at all. So you need to have an action. So collect is one of the action here. And now there is one more responsibility of the collect. I mean one more functionality of the collect. It is not only an action, there is some other functionality associated with the collect. Now the way the data is stored, we all know that the way the data is stored in HDFS. In HDFS, we know that the data is stored in blocks. If a file is, let's say we have our sales.csv file. If the sales.csv file, let's say its file size is 384 MB, and it is divided into blocks, block 1, block 2, and block 3. Each block is, block size is 128 MB. We know that. Each block is divided into 128 MB. And these blocks are distributed. So let's say block 1 is in system 1, block 2 is in system 2, block 3 is in system 3. So for whoever is new to this, I would recommend just to go through a HDFS video on YouTube. I have my HDFS video on YouTube. Just go through that. It will just take 1 hour of time, one hour or 1.5 hours of your time. You should be able to understand the complete details about the HDFS. So this is how the data is stored. The sales.csv will be divided into blocks and stored in different systems. Now, whenever we use a text file API to read, each block will be read by a task. I will come to those details. Some thread will be reading this block. One more thread will be reading this block. One more thread will be reading this block. So 3 threads will be reading these 3 blocks, and here we'll have some data. So it will return some part of the data. So this task will be having some part of the data. So this task will be reading some part of the data. So this is nothing but our RDD. So RDD is nothing but, as I said, it's a collection of records. So here we have few records, here we have few records, and here we have few records. So that's how our RDD looks like. As I said, RDD is divided and distributed into across the nodes in the cluster. The same way is here. So this is our RDD. Here may be some 5 records, here may be some 6 records, here may be some 4 records, something like this. So that's our RDD. Now whenever we use a collect, whenever we use a collect, so collect will not only evaluate this lazy transformation, nothing will be read from the file system yet. It will be only read when you call the collect method, as I said earlier. Along with that, the one more functionality is it will bring all these records to a single system. All this record will also come here whenever you call a collect. The records that are available in system 2 will also come here. The records that are available in system 3 will also come here. So that's the one more functionality of collect. It will be collected and stored in the memory of this system, and the data structure that is used to represent the data is an array. So collect method returns an array, meaning all the records from different systems are stored in the single system here. That's nothing but our collect. So you have to be very careful while using the collect method, because storing the data in a single system's memory may not be a feasible solution. It may crash your that system. This system may be crashed and all your data may be lost, because your file may be here 384 MB, but it could be sometimes some 6 GB something, or 10 GB something. Your file size may be 6 GB. Your memory here, memory could be 4 GB. So if the memory of a single system is 4 GB, how can you fit a 6 GB of data in this 4 GB? Obviously, it will run out of memory and your application may crash. So it is not recommended to use the collect method unless you know the size of your file. Size of your RDD collection. If you know that in upfront, you know that your data will be very less, so in that case you can use the collect. Otherwise, it is not recommended. It will crash your one of the system here. So I hope the collect method was clear. I hope the transformations were clear. I hope the actions were clear. I hope the textFile API was clear and the collect API was clear here. We know that collect returns an array. On this RDD collection, we are calling the collect method. It returns an array. Now the only reason I'm converting to a list, the only reason I'm converting to a list is to just for the display purpose. Otherwise it is not required, because the array, it does not print the elements of the collection. Array will print the address of the collection. That's the only reason. So let's run this program. So how to run this program? Select this load data, or go to the edit run tab. Go to the run tab here. go to edit configuration, specify the input parameters. The very first parameter is local, which is nothing but our master here. As you can see, the first argument we are taking it as a master, and master is nothing but our first parameter to the Spark context. I have to explain that, we haven't seen that yet. Our next parameter is the path of the file. So our file exists in the resource folder, so I'm giving the relative path. From our working directory is Spark Core. Inside that Spark Core folder, we have the code folder, then source, main, resources, and inside that we have the sales. So we are giving just the relative path: code, source, main, resources, sales.csv. So we can check here as well. We have our sales.csv file. So let's run this program and check the result. It will just display the contents of your collection. That's all. Right click and run. That's all. So as you can see here, it has exited with code 0, means it has successfully run the program. And we are getting all our data as a list here. So data from here we are getting as a list. So all these are, we have read it from the textFile API, from which we got an RDD. Now RDD was converted into a list to just for the display purpose. So this is how we read the data. So I hope till here things were clear. How to read the data from the file system. Now we have to see what is this first parameter. We have to see what is this first parameter. To understand that, I said that when I say Hadoop, Hadoop means HDFS and YAR. So this is our HDFS. So to have the HDFS, we know that we need to have our data node services up and running, and our name node service should be up and running. In a similar fashion, for the yarn, it has to be the node manager services has to be up and running, and our resource manager service has to be up and running. So this is our Hadoop cluster, where the operating system is available and the file system is available, and any application that you want to run, that applications, let's say in our case it is a Spark application. So that Spark application 1 that has to contact name node service to read the data from the file system, and it has to contact the resource manager to ask for the CPU core and RAM. So CPU core and RAM will be given by the resource manager. Disk related or storage related queries will be addressed by the name node service here. So here the first parameter is nothing but the resource manager. So if you want to run any application, underlying operating system should be up and running. And in our case, in case of the Hadoop, the main operating system, I mean the master of the operating system is nothing but resource manager. So resource manager has to be the master here. But not only that, but we have specified local there. The reason is because when Hadoop was started, when Hadoop was started in the sense released. When Hadoop was released, there existed only HDFS file system. There did not existed Yarn at all. There existed MapReduce. When Hadoop first release was done, there existed only HDFS and MapReduce. Yarn did not exist. Yarn was taking the responsibility of processing data as well as it was taking the responsibility of the operating system. It was doing both the responsibilities. It was taking how to allocate CPU core and RAM. All those stuffs was also taken care by MapReduce, which was not a feasible solution. Your application should not be treated as a operating system. So that there did not existed any operating system at all during the early days of Hadoop. Later we know that Hortonworks started developing Yarn. And at the same time at MIT Labs, since there did not existed any operating system, a generic purpose operating system for the Hadoop ecosystem, at the same time in MIT they started developing Mesos. So as of now, two generic purpose operating systems are available. Generic purpose, two operating systems are available. Now our Spark application should be able to run on any of the application. I mean to say, if you develop any application for mobile applications, you have to make sure that it has to run on Android OS as well as iOS. You should not make it is only available for one of. So that's the reason Spark should also be compatible on running Yarn operating system or Mesos operating system. Similarly, Spark itself has a module. The Spark framework itself has a module which acts as an operating system. So that we call as a standalone mode. Spark standalone. The name is a bit confusing here. Standalone doesn't mean it is a single system. Standalone still means it is a distributed operating system or a cluster manager. The only thing is you can only run Spark applications on this. Here it is a generic purpose operating system. It's a generic OS, I will say. Most of the time people call it as a cluster manager. So I'm just referring for similarity purpose. Generic OS meaning you can run Spark job, you can run MapReduce job, Hive job, Oozie job. All these jobs can be run on Spark, on Horton, sorry, on Yarn or Mesos. But on the Spark standalone, you can only run Spark application. But all are distributed here. All are running on a cluster. It's a distributed cluster. Just like we have. So if I take this example, this is our Hadoop cluster where we have data node services and name node service for HDFS, node manager service and resource manager service for Yarn operating system. So if it is a Hadoop cluster, if it is a Mesos here, if it is a Mesos cluster, so instead of your node managers and resource manager, some other daemons will be running. If it is a Mesos cluster, it will be something called as workers. They call it as workers. And they name it as, the jargon they use as a master. If it is a Mesos cluster. So master is the one which will handle CPU core and RAM. CPU core and RAM here. Now when we say Mesos master, this we call as Mesos master. So these are all, we know that JVM processes or daemons running. So it will be running on some IP address and port. In a similar fashion, if it is a Yarn cluster, Yarn will also be running on some IP address and port. Mesos will be running on IP address and port. If you are having a Yarn cluster, in Yarn cluster, uh, I mean to say, Yarn master will be running also on IP address and some port. This is port X, some port Y. Similarly, if you have Spark standalone, it will be also running on some IP address and some port Z. The master will be running on some port. So the first parameter is nothing but that. The first parameter to our Spark context API is nothing but the master of your cluster manager, or the master daemon of your Hadoop cluster, or if at all it is a Mesos, then it is a Mesos master. If at all it is a Spark standalone, it will be the Spark standalone master daemon, which is nothing but the IP address and the port of those daemons. So in case you are running it on a cluster, if you want to run it on a development environment, every time you cannot run on the cluster, you have to test it on your development environment. So for the development environment, it is nothing but local. Local means single JVM. So everything will be in one JVM. But in case of a distributed, every system will have its own JVM. It will have its own JVM. So the usually the workers, what they will do is they will allocate CPU core and RAM. They will allocate CPU core and RAM as the JVM. They will allocate JVMs, meaning CPU core and RAM will be given here. So your processes or threads will be running inside this JVM. We'll come to those part. We'll come to those part. But when we say local, everything is running on a single system. Usually it will be on your laptop. So that's the difference between local and normal other distributed file system. Out of this, these two are generic cluster managers or generic OS or cluster manager, I will say. And Spark standalone is only Spark applications can run on that. So I hope till here things were clear. Any questions still here? Okay. So if there are no questions, and I assume it is clear to everybody, and on what is the first parameter of our Spark context. The idea here is you can run this program. You can run this program on a Yarn cluster. You can run this program on a Mesos cluster, or you can run this program on the Spark standalone cluster also. You have to just specify the IP address and port of the corresponding master service of each and every operating system, distributed operating system. The IP address and port of the master service. That's the main thing which is required. Otherwise, we have only also seen what is textFile API and what is a collect API. Next, we'll see one more example. And with respect to that example, we will try to understand the architecture of a Spark, how internally things works, because that is important to understand how the things work here. So to understand that, we'll see the next example how things work. So if you go and see the next example in that document, so next example is nothing but item wise count. A simple example to understand the architecture of our Spark. So item wise count, again you can use this file name and search in our project. Control Shift N is to search. So you can search for item wise count. Yeah, here the password is Kafka123. Just to clarify, the username and password of my Ubuntu system. Username is Kafka and password is Kafka123, and everything is small. Lowercase Kafka123. Now this is our item wise count example. Our item wise count example. Now what do we mean by item wise count? So counting how many times an item has occurred on our sales transaction. So on this sales, this is our sales transaction. Each record is a sales transaction that has happened, meaning that product has been sold. This item has been sold. Now, doing an item-wise count, what we will get? We'll say that item ID has occurred once, twice, three times, four times, or five times. So, item ID has been sold. Item ID 333 has been sold five times. Item ID 222 has been sold some four times. So by doing an item wise count, we can get to know which item has been sold how many times, which is the highest selling item, which is the least selling item. So such kind of an analytics we can achieve by doing the item wise count here. Now how do we do the item wise count? Because our data is, let's assume our data is distributed and stored across the system. So we have a transaction ID, customer ID, item ID, and item value is 40 rupees. Let's assume that. Transaction ID 112, 113, 114. 50 rupees, 60 rupees, 70 rupees. Transaction ID 115, 116, 117, and 118. 119, 120, and 121, 122. So let's say this is our sales.csv. This is our sales.csv, which is available in different system. Let's say this is node 1 or system 1. This is on system 2. This data is available on system 3, which is nothing but this is block 1, block 2, and block 3. So this is how the data is divided and stored on the HDFS file system. Whenever you have the, if I say the data is available on the HDFS file system, it is available in the form of blocks, and let's say each block is of size 128 MB. Now how do I do the item wise count here? Because all this data are in different system. All this data are in different system. How can we do a count? Because if I run a simple Java application or some other application, Python based or any language based simple program, if I write, I have to run that program on only one system. So it will only do the count. If I run it on system 1, it will only do the count on system 1. It will say item ID 222 has been sold only two times. Item ID 333 has been sold only once. Similarly, item ID 444 has been sold only once. But we want to have the global count. So our final result should be what? Our final result should be item ID 222 has been sold six times. Our final result should be something like this. 222 has been sold six times. Our item ID 333 has been sold. Let's make this also as 333. This is also will make it as 333. So item ID 33 has been sold 4 times. So it should be 333, 4. In a similar fashion, item ID 444 has to be item ID has to be 2 times because it has been sold 2 times. How do I achieve this? How do I achieve this? Because in a distributed processing, it's not so straightforward to achieve this. We know that. So one golden rule here, one golden rule in a distributed processing, whenever you want to do aggregation, because here count is also an aggregation. In distributed processing, all similar records should be transferred to all the similar records should be transferred to single system. Now what do I mean by similar records? Now when I say similar records, it depends on problem statement. Now what is our problem statement? Our problem statement is to do item wise count. So here our problem statement is item wise count. As a result, all the record here, similar records means records with the same item ID. Records with the same item ID are our similar records. Now all the records with the same item ID we should bring to one system. So general a golden rule for any aggregation that you want to do in distributed system, all similar records should be transferred to single system. Only then we can do the aggregation. Obviously that makes sense. As you can see, if I bring all the records with item ID 222 to a single system, if I bring everything to a single system, obviously I can loop through all those records. I can loop through all those records and I can just say count as whenever I see a record, first record I will say count 1. Whenever I see the second record, I will increment that count. Whenever I see the third, keep on incrementing, and finally you will get the total count. If at all we are bringing it to a single system, and we have to bring it, that's how the aggregation will work in a distributed processing. There is no other way to achieve aggregation. The only way to achieve an aggregation in a distributed processing is, or a distributed application is, to bring the similar records to a single system. Once we have all the similar records to in one system, you can do the aggregation. Otherwise it is not possible. And similar records depends on the problem statement. In this case it is the item wise count. So all the records with the same item are our similar records. Now the question arises, how do we bring all the similar records to a single system? How to transfer? How to transfer similar records to a single system? Actually, Spark framework handles this. Spark framework handles transferring similar records to single system. Now, how does the Spark handle this? How does Spark handle of bringing similar records to a single system? Now, earlier, if you remember, we talked about tuple data type. We talked about tuple data type. Tuple data type is nothing but gathering of similar records. Sorry, gathering of different data types into one data type. Now, I also said that the greatest or the biggest use case of a tuple data type in distributed framework is as key value pair. Spark treats a two-element tuple as a key value pair. It always treats a two-element tuple as a key value pair. Whatever is the first element is the key, whatever is the second element is the value. And the Spark handles transferring of similar records to a single system with the help of key value pair. Now what Spark does is it will transfer all the similar records. I mean to say, uh, the Spark will transfer all the records with the same key to one place. Spark always does that. It will transfer all the records with the same key to one place or one system. Now it is a developer's responsibility to put item ID as your first element of the tuple. As a result, Spark will treat the item ID as the key and it will bring all the records with the same key to one system. So Spark treats a tuple as a key value pair. Now the developer's responsibility is to transform this a string. Each element is a string we know. Transform this string into a key value pair. Now key has to be the item ID here, because later Spark will bring all the records with the same key to single system. Our responsibility is only to put the key as the first element of the tuple. Second element will say as 1, because later all the ones will be added and you will get the count. In a similar fashion, 333 1, 444, 1, and again 222, 1. So we have to transform this. We have to transform it into a key value pair. Now how do I transform this? How do I transform this? We have to transform every record from a string to a tuple. So whenever we want to transform every record from a string to a tuple, what we do is we usually use a map higher order function. We usually use a map higher order function. So you can write a, just to show how can we use. So you can define a function called getTuple. You can define a function which takes a string, because the input data type to the function should be same as the collection data type. Our RD is a collection of string. So if we haven't seen that, so we can always check that. Whenever we read the data from the textFile API, we know that we get a RDD collection. The data type of that is nothing but, you can hover wherever that RDD is being used, wherever that identifier is being used, just press the control button and hover on that. You will always know the data type. As you can see, it is a RDD of string. So if at all we are using a map higher order function which takes a function, and we know that that function will be called for every record of the collection, so it has to map the data input parameter of that function should be same as the collection type. So since the collection is a string, our input data type should also be a string. Now string, so each record is a string, we know that. We know that each record is a string. Now we know that we can use a split method. We have also seen the split method which can split this based on the comma separated. So I can say val columns, which is nothing but an array, because split method returns a array, we know that. Split that string, split that string by comma. We get a array. So array of 0, array of 0 will be this, array of 1 will be this, array of 2 will be this. So we extracted our item ID. So we extracted our item ID and we will return a tuple. We can say columns of 2, array of 2 will be the item ID, which will be the first element of the tuple, and I will say count as 1. So as you can see, it takes a string, this function takes a string and it returns a tuple, So we can apply it on a simple collection. I will just show it as a simple collection. Val records is equal to, we can use a list here, a list of simple string. This is the first element. I will take 2 elements here. This is our second element. Just for understanding purpose, we are having a list collection here. So we have a collection of string. This is our first element and this is our second element. And we want to transform this collection into a collection of tuple. So obviously we can use our map higher order function. Map and pass the get tuple here. So as you can see here, this get tuple was called for this string first, and from that it extracted 333 and made it as the first element of the tuple and count as 1, and similarly 222 as 1. So this is how things work. In a similar fashion, we also know that we need not define the function, we can directly use this function literal. So we also know that we can directly use the function literal. Just for understanding purpose, I will only thing we have to change is equal to from equal to. So I can directly use this function literal. We also know that we need not specify the data type. Function literal, we can directly pass this. Instead of get tuple, you can directly pass this function literal and we should get the result. And that's what we are doing in our program. This is what we are doing in our program. As usual, we are creating our Spark context. As usual, we are reading our file using the textFile API. we get a RDD. Once we get the RDD, we are transforming that RDD, which is an RDD of string. We are transforming that RDD into an RDD of tuple. A collection of string has been transformed to a collection of tuple. So this piece of code does this. This will be running in parallel. We will understand that parallel computation as we learn the architecture. But I hope this was clear. It is a developer's responsibility to transform the data into a tuple. Now, why do we want to transform the data into a tuple? Because Spark treats a tuple as a key value pair. So here it will treat that item IDs are the key. Sorry for that. Is there any disturbance? Is there any disturbance here?
No, Prabhu.
Okay, okay. So as I said, 2 to 2. This is we transformed into this fashion because Spark will bring all the records with the same key to a single system. That's the reason we have transformed into a key value pair. Spark will treat the first element as the key and the second element as the value. Now how it will do here? How it will do? So after doing map transformation, we got this. Everywhere this map higher order function will be running. I'll make it as a bit simpler here. 2 to 2, 1, 3 3 3, 1, 4 4 4, 1, and again 2 to 2, 1. And here also it is 3 3 3, 1. This we wrongly typed here. I think here also it is 3 3 3, 1. So I will finish this example, otherwise the one example I don't want to be in two different videos. So let's finish this example. Now for the Spark to bring all the records to a single system, there is some API that has to be called. So that API is nothing but a reduce by key. Just like we have reduce, so we have reduce by key as well. So just like reduce takes two parameters, here also we have reduce takes by key takes two parameters, and you can specify your logic here. Now what is reduce by key? What is reduce by key? We know that reduce takes all the elements of a collection and returns a single element. It aggregates. Reduce is for aggregation. It takes all the elements of the collection and gives a single element. In a similar fashion, what is reduce by key? Here also it does the same thing. It takes all the elements of the collection and gives a single element for each key. It will do it for each key. For each key, as you can see here, multiple values are there. So 2 to 2 can be considered as 1 comma 1. Here also 2 to 2 can be considered as, there are two ones. There are two item ID 2 to 2 has been occurred twice. Similarly here also 2 to 2 comma 1 comma 1. Here also 333 comma 1 comma 1. So reduce by key, what it does is it aggregates all the values for each key. Here for reduce, the collection is this values. It will reduce all the values to a single element for each key. So that's what the reduce by key does it. First local aggregation will be done. First local aggregation will be done. Second, calls Spark module, calls a Spark module which transfers all records with the same key, which is nothing but item ID here, to single system. Third point is global aggregation. So reduce by key, what it does is it does a local aggregation first. The reduce logic will be applied. The logic that we have seen in our Scala. It's the same logic for each key it will be doing. So we know that X is the accumulator. X is the accumulator. It will be pointing to the first element of the collection. Y will be iterator. It will be iterating from the second element to the last element. Here we have only two elements. In a similar fashion, X will be here, Y will be iterating. For every unique key, there will be a reduce happening. For every key, there will be a reduce happening. X will be this, Y will be iterating from here. X will be initialized to the first of the collection, Y will be iterating from the second element. As a result, it will do, as a result, what we'll get is 2 to 2, comma 2. So this will be gone, this will be gone, these things will be gone here. Instead of this, you will have 2 to 2, comma 2, 333, comma 2. So local aggregation has been done. I hope you got the idea here. So local aggregation is done here, local aggregation done. Then calls the Spark module. I said that Spark will take care of bringing all the records with the same key to a single system. Here key is the item ID. It will bring all the records with the same item ID to a single system. So 222, comma 2. Again we have 222, comma 2, 222, comma 2. Similarly, we can get 333, comma 1, 333, comma 1, and 333, comma 2. Similarly, we can get 444, comma 1 and 444, comma 1. As you can see, all the records with the same key are in one system. So from here, the Spark will take care of this, transferring all the records from the different system to a single system. Spark will take care of bringing all the records from different system to a single system using that key value pair. So all the records from different systems, oh, my mistake. Now everything is fine here. 222 from here has come here, from here also it has come here, from here also it has come here. All the records with item ID 333 has come to one system. 333, 1 from system 1, from system 2, and system 3 has come to, we can say, system 5. This is our system 6 or system 4. All the records with item ID 444 also has come to system 5. We can get records from different system to different systems with the same key to a single system, but not to different systems. So I hope this part is clear. This is taken care by the second step, Spark module, which transfers all the records with the same key. Now again, the global aggregation will happen, which is nothing but the logic that we have written in the reduce by key. Again that logic will happen. So internally it will be 222, 2, 2, 2. So X will be having this, Y will be iterating from here to here. X will be initialized, which is an accumulator. It will be initialized to 2, first element of the collection, and Y will be iterating from the second element to the last element, and whatever logic is given, that will be evaluated and stored back in the accumulator. So finally we should get 222, 6. In a similar fashion, 333, 2, 1, 1. Similarly, 444 will be 1, 1. So finally we should get 333, these things should go off, and finally we should get 333, 4 and 444, 2. So that's how the reduce by key works. First it will do the local aggregation based on our reduce logic. Reduce by key is nothing but do the reduce for each key. You will have a collection of ones and collection of ones, reduce it to a single count, and finally you should get the end. So I hope how internally the item wise count works. So you have to just do a aggregation. Here if you want to do a count here, hence the logic is x plus y. What logic you give depends on your problem statement. It need not be x plus y always. It could be something else also. So that's what we are trying to do here. Whatever data frame, whatever RDD we get, our item pair RDD. Sometimes it is also called RDD of tuple is called as a pair RDD. So you might hear a lot of jargon on pair RDD on the internet. Pair RDD is nothing but a tuple, RDD of tuple. Each element of the RDD is nothing but a tuple, where first element will be treated as the key, second element will be treated as the value here. Now forget about this. The 2 we will see later. On that we just do a reduce by key, and we just say take x comma y, x plus y. So it is only the value part. We are aggregating the value part. The logic that we write here is only the value part. Once we have that, we are sorting here. What will sort do? We know that how the sort by higher order function work. You can pass any function, whatever is the return value from that function. Based on that return value, the sorting will be happening. So with this, our RDD is nothing but in this fashion. I will just in some other form. Our final RDD is nothing but we have 333, comma 4, we have 444, comma 2, and we have, this is after reduce by key, and 222, comma 6. After reduce by key, we are having this RDD after doing the reduce by key. Now I want to sort it by the second element of the tuple. We want to sort it by the second element of the tuple, and also we want to sort it by the uh, sort it in the descending order, so that we can get the highest selling item as the top element. After doing reduce by key, after doing reduce by key, so we are having this. I'm just putting it in a single. It will be on different system. This RDD will be on different system. So after this, when I say sort by, so when I say sort by, I want to sort it by the second element of the tuple. Now how do I return the second element of the tuple? Underscore a tuple t dot underscore 2. This is our second element of the tuple. If t is the tuple, but in case of sort by, it takes a higher order function. That function takes each element. Now each element could be a underscore. We know that we can have a placeholder for underscore. Underscore dot underscore 2 will return the second element of the tuple. But will it sort in the descending order? It will not. We know that by default it sorts in the descending order. Adding a negative sign sorts in the descending order. We have seen that, and that's what we are doing here. We are sorting in the descending order of our collection. And I said that our transformations are lazy. This is lazy. Reading the data from the file system is lazy. Doing the map transformation is lazy. Reduce by key is lazy. Sort by key is lazy. Nothing gets evaluated unless you call an action. Unless you call an action. Map is lazy. Reduce by key is lazy. Similarly, sort is also lazy here. Only when we call an action, which is in this case we are using save as text file. Only this action will be taken care. Only when we call this action, the whole lazy transformations will be evaluated. And when you say save as text file, will save the data to the file system. It is an action. It is an action as well as it will save the data to the file system. So you need to specify the path. This path could be local file system path, it could be HDFS file path, it could be S3 file path, or it could be Microsoft Azure file path. Any path it could be given. So let's run this program. So before saving this, so we have to delete the existing folder. Item wise count output we already have there. So just delete that and rerun this program once again. The same input parameters, local I am giving, the input path I am giving, and the output path also I am giving a folder inside the resource directory. Meanwhile it runs. So one more thing I wanted to say, here transferring all the records from different system to different systems. So we are transferring the data from system 1, system 2 and system 3 to system 4 and system 5 so that all the records with the same key comes to one system. So the transfer is happening from multiple systems to multiple other systems. So such transfer of data is called as shuffling. So if there were 1 million records, all these 1 million records will be transferred across the network. If there are 10 million records, almost all the 10 million records will be transferred across the network. So data transfer happens a lot with respect to shuffling. So shuffling is a expensive operation. So the first is local aggregation. The second point that I have described, which is taken care by the Spark, which will internally trigger the shuffling, and shuffling is expensive operations. So I hope we got to know what is shuffling here. Shuffling is nothing but transferring multiple records, transferring the records from multiple systems to other systems so that we bring all the records with the same key to one system. That itself is called as shuffling. Now as you can see here, it has exited with code 0, means that it has successfully exited, successfully run the program, and we have our file return. So as you can see here, as you can see, we have item wise count 333 has been sold 5 times, item ID 222 has been sold 4 times, item ID 666 and 444 has been sold 3 times. So this is how the aggregation happens. So golden rule is 1. For any aggregations, all the records with the same key should come to one system. Only then aggregation can happen. Bringing all the records, similar records, to a single system itself is called shuffling. And similar records depends on your use case. In our use case, it was item wise count, hence item ID has to be the key. So if you want to say total amount per customer, I want to compute a total amount per customer. So you can try that example. Try that example, compute total amount per customer. So you have to choose what will be the key in that case. What shall be the key in that case if I want total amount per customer? So that all the amount per customer should come to one system. Similar customer should come to one system. So in that case, obviously, customer ID will be the key. So your first element of the tuple has to be the customer ID. Just try that example if you want. Total amount per customer. Compute total amount per customer. So I hope the item wise count example was clear, and how internally things work. I hope those were clear. So tomorrow what we'll do is, taking this example, we will try to understand the complete architecture of Spark. The complete architecture of Spark. So let's wind up the session here and continue tomorrow. If at all you have any questions, please to ask the questions. I mean, in between also you can always ask the questions, not that we have to always ask the question at the end of the session. In between, anytime you have a doubt, anytime you have a question, please to ask the question. Here is a question. I think Thiru has sent it in a private window. The question is, how do we display the entire row information whose count is greater than x. Here count, you are saying the item wise count. Are you saying the item wise count? Okay. So in that case, your second element of the tuple, should be not just the count, it should be the record as well. I mean to say, as of now, how do we are transferring our data? Our item ID and count 1. So instead of that, 222, comma, complete record. Our second element of the tuple will be complete record, a class with the count as well. Probably in this case, sales record and count should be there. I mean, your logic will be separate now. Your logic will be separate. So you will have a class sales record and count will be there. So in this fashion. So I hope you got the idea. Sales record will have transaction ID, customer ID, item ID, item value. Now your reduced logic will be different. On which item you have to count, you cannot just say x plus y. You cannot say x plus y. You have to get the x is nothing but x and y will not work. Some trick has to be done. I will write. You can try it. I will write the program and I can share this. I will share the code for it if it required, but just try this. So your value will not be just a simple one, it will be some count. Custom sorting is also required. Custom sorting is also required. I will share the code, but I would say try this, because your only thing idea here is your value part should also be the record. Along with the count, you should also have the record. The question was something like this. The question was, no, record. No, the question is a bit conflicting. One record does not have the count, right? You want all the records whose count is greater than x. Combination of multiple records, the count will be greater than x. So here you are just simply specifying the count as okay. The whole discussion was as fall apart. The whole discussion was a wrong discussion here. Based on this question, the whole discussion was a wrong discussion, because the count that will get is based on multiple records, but we cannot have that multiple records. as displayed. The count that we got is for customer ID, item ID 222. We have counted all the item ID 222. So that way we got our count. You can have the question. I think the better question would be display all the records whose item value is 100. It should be something like that. Display all records whose item value is greater than 100. This question makes sense. I hope, Thiru, that you got the idea here. This is a slightly, I mean, it is not a correct question. My discussion also was wrong actually. The question should be something like this. Display all records whose item value is. So we cannot have this. This is a conflicting question. We cannot have a single record whose total count is greater than X. It doesn't make much sense. So this makes sense. Get me all the records. But we have already seen such kind of a thing. If you remember, we used the filter higher order function for our users collection, user list, and we said that give me all the records, give me all the records whose salary was greater than 8,000. We saw that. So such filter higher order function can be used in this case. The item ID 333. Okay, you want to specify the details about item ID 333. So item ID 33 we have, but how can you? So in that case, that you need to have the item IDs details in a separate file. Like what is that item ID, item name, item description. So those things will be in a different file. Obviously, we have to join in that case. So we have to join in that case. That we will see later. How to specify the details about the item ID, we will see that later. Group by 333 and display the row for order. No, the thing you are saying here is, if I, so what you are trying to say here is, so you are just saying item ID 1113 and you are saying 5 here. I mean, that usually doesn't, it doesn't make much of a use here. This is what you are trying to say, right? But it usually doesn't give any reference or any, we don't understand what is this. Why is item ID 111333, item ID 33 is associated with 5? It doesn't make much sense. Right, different scenario is something like it would be 333, 333 could be iPhone, description would be iPhone 8, blah 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 something, and count is 5. This would have made sense. This would have made sense. Now to do this, you need to have the name of the item, the name of the item, and the description of the item. Name of the item and that will be available in a different data. It may not be available in sales.csv. It will be in products.csv. It will be available in products.csv. Now products.csv has to be joined with the sales.csv. So that we will see later. Whenever we do the join operation, we will see that. It is part I will explain that. Yes, yes. Yes, we will see that. We will see that. Yeah, yeah. Thanks everybody. Good night and have a nice day, others. Good night and have a nice day. Thank you.